Chapter 1. Knowing our numbers. Introduction. Counting things is easy for us now. We can count objects in large numbers. For example, the number of students in the school and represent them through numerals. It is not as if we always knew how to convey large quantities in conversation or through symbols. Many thousands years ago, people knew only small numbers. Gradually, they learned how to handle larger numbers. They also learned how to express large numbers in symbols. All this came through collective efforts of human beings. Their path was not easy. They struggled all along the way. In fact, the development of whole of mathematics can be understood this way. As human beings progressed, there was greater need for development of mathematics, and as a result, mathematics grew further and faster. We use numbers and know many things about them. Numbers help us count concrete objects. They help us to say which collection of objects is bigger and arrange them in order. Example: first, second, etc. Numbers are used in many different contexts and in many ways. Think about various situations where we use numbers. We enjoyed working with numbers in our previous classes. We have added, subtracted, multiplied, and divided them. Comparing numbers. As we have done quite a lot of this earlier, let us revise this with some examples. Example: find the greatest number given below. 1, 92, 392, 4456, 89,742. 2, 9,201, 9,021, 9,210. Solution: 1. 89,742 is the greatest number because among all the numbers in the given row, 89,742 has the highest number of digits. 2. 9,210 is the greatest number. In the given row, the numbers have the same number of digits. Further, the digits at the thousands place are also same. So, we move to the next digit, that is to the digit at the hundreds place. The digit at the hundreds place in 9,210 and 9,201 is same. So, we move to the next digit, that is to the digit at the tens place. The digit at the tens place in 9,210 is greater than in 9,201. Therefore, 9,210 is the greatest number. Remember, in the given numbers, one with more digits is the greatest number and less digits is the smallest number. If the number of digits in two given numbers is the same, then we look at the next digit, that is hundreds, tens, and ones, and so on. Example: find the greatest and the smallest numbers in each row given below. 1. 382, 4,972. 18. 59,785, 750. 2. 1,473, 89,423, 100, 5,000, 310. 3. 1,834, 75,284, 111, 2,333, 450. 4. 2,853, 7,691, 9,999, 12,002, 124. 5. 15,623, 15,073, 15,189, 15,800. 6. 25,286, 25,245, 25,270, 25,210. Solution: 1. 59,785 is the greatest and 18 is the smallest number because in the given row, the number 59,785 has the most number of digits, while the number of digits in 18 is the least. 2. 89,423 is the greatest and 100 is the smallest number because in the given row, the number 89,423 has the most number of digits, while the number of digits in 100 and 310 are the least, and both numbers have the same digits. Further, if we compare the digits at the hundreds place in both these numbers, we find that 1 is less than 3. Therefore, 100 is the smallest number. 3. 75,284 is the greatest and 111 is the smallest number because in the given row, the number 75,284 has the most number of digits, while the number of digits in 111 and 450 are the least, and both numbers have the same number of digits. So further, if we compare the digits at the hundreds place in both these numbers, we find that 1 is less than 4. Therefore, 111 is the smallest number. Four. 12,002 is the greatest and 124 is the smallest number because in the given row, the number 12,002 has the most number of digits, while the number of digits in 124 is the least. 5. 15,800 is the greatest and 15,073 is the smallest number. The number of digits in all the numbers given here is the same. Further, the digits at the 10,000 and thousands place are same. So, we move to the next digit, that is to the digit at the hundreds place. If we compare the digits at the hundreds place in numbers 15,800 and 15,073, we find 8 is greater than 0. So, 15,800 is the greatest and 15,073 is the smallest number. 6. 25,286 is the greatest and 25,210 is the smallest number. Number of digits in all the numbers given here is the same. Further, the digits at the 10,000, thousands and hundreds place are same. So, we move to the next digit, that is to the digit at the tens place. If we compare the digits at the tens place in the numbers 25,286 and 25,210, we find that 8 is greater than 1. So, 25,286 is the greatest and 25,210 is the smallest number in the row. How many numbers can you make? Suppose we have 4 digits 7, 8, 3, 5. Using these digits, we want to make the greatest number and the smallest number. We know the ascending and descending order. We use it to make the greatest and the smallest number. For the greatest number, we use descending order of given digits. Descending order of 7, 8, 3, 5 are 8, 7, 5 and 3. So the greatest number is 8,753. For the smallest number, we use ascending order of the given digits. Ascending order of 7, 8, 3 and 5 are 3, 5, 7 and 8. So the smallest number is 3,578. So the greatest number is 8,753 and the smallest is 3,578. Let's solve some examples. Example: use the given digits without repetition and make the greatest and the smallest 4-digit numbers. A. 4, 7, 5, 0. B. 5, 4, 0, 3. C. 9, 7, 4, 1. Solution: A. 4, 7, 5, 0. Descending order of the given digits is 7, 5, 4, 0. So the greatest number is 7,540. Ascending order of the given digits is 0, 4, 5, 7. But 0457 is a 3-digit number. So we put 0 in hundreds place. So the smallest number is 4,057. B. 5403. Descending order of the given digits is 5, 4, 3, 0. So the greatest number is 5,430. Ascending order of the given digits is 0, 3, 4, 5. But 0345 is a three-digit number. So we put 0 in hundreds place. So the smallest number is 3045. C. 9741. Descending order of the given digits is 9741. So the greatest number is 9741. Ascending order of the given digits is 1479. So the smallest number is 1479. Stand in proper order. Here, the height of Ramhari, Dolly, Mohan and Shashi are given in centimeter. A. Find the tallest and the shortest height among them. And B. Arrange them in the increasing order or decreasing order of their heights. Let's find the solution. Ramhari is the tallest and Dolly is the shortest. Increasing order of their height is Dolly, Mohan, Shashi and Ramhari. That is, these children are arranged from shortest to the tallest. So, this arrangement is of the form from smallest to the greatest. Decreasing order of their height is Ramhari, Shashi, Mohan and Dolly. This arrangement is of the form from greatest to the smallest. Ascending order. Ascending order means arrangement from the smallest to the greatest. Descending order. Descending order means arrangement from the greatest to the smallest. Let's solve some examples. Example. Arrange the following numbers in ascending order and descending order. A. Rupees 2,635. Rupees 1,897. Rupees 2,854. Rupees 1,788. Rupees 3,975. B. 9,801. 25,751. 36,501. 38,802. C. 5,000. 7,500. 85,400. 7,861. Solution. A. Rupees 2,635, Rupees 1,897, Rupees 2,854, Rupees 1,788 and Rupees 3,975. Ascending order means arrangement from the smallest to the greatest. That is, Rupees 1,788, Rupees 1,897, Rupees 2,635, Rupees 2,854, Rupees 3,975. Descending order means arrangement from the greatest to the smallest. That is, Rupees 3,975, Rupees 2,854, Rupees 2,635, Rupees 1,897, Rupees 1,788. B. 9,801, 25,751, 36,501, 38,802. Ascending order: 9,801, 25,751, 36,501, 38,802. Descending order: 38,802, 36,501, 25,751, 9,801. C. 5,000, 7,500, 85,400, 7,861. Ascending order: 5,000, 7,500, 7,861, 85,400. Descending order: 85,400, 7,861, 7,500, 5,000. Shifting digits. Have you thought what fun it would be if the digits in a number could shift or move from one place to the other? Let us understand this with an example. For example, let's take a number 182. If we put the digit at units place in 182 at hundreds place, then we get two numbers, 218 or 281. In the same way, if we put 1 at units place, then too we get two numbers, 821 or 281. Also, if we put 8 at hundreds place, again we get two numbers, 821 or 812. For forming the smallest and biggest numbers, the digits are arranged in ascending and descending order. In the same way, by interchanging the digits, we can form new numbers. Introducing 10,000. We know that beyond 99 there is no two-digit number. 99 is the greatest two-digit number. Similarly, the greatest three-digit number is 999. And we add 1 to 999 to make 1000. Look at the pattern. 9 plus 1 is equal to 10, which is equal to 10 into 1. 99 plus 1 is equal to 100, that is equal to 10 into 10. 999 plus 1 is equal to 1000, which is equal to 10 into 100. We observe that Greatest single digit number plus 1 is equal to smallest two-digit number. Greatest two-digit number plus 1 is equal to smallest three-digit number. Greatest three-digit number plus 1 is equal to smallest four-digit number. We should then expect that on adding 1 to the greatest four-digit number, we would get the smallest five-digit number, that is, 9,999 plus 1, which is equal to 10,000. The new number which comes next to 9,999 is 10,000. It is called 10,000. Further, 10,000 is equal to 10 into 1,000. Revisiting place value. You have done this quite earlier, and you will certainly remember the expansion. Let's revise with a few examples. Example 1. 78 is equal to 70 plus 8, that is equal to 7 into 10 plus 8. 2. 278, that is equal to 200 plus 70 plus 8, which is equal to 2 into 100 plus 7 into 10 plus 8. Here, 8 is at 1's place, 7 is at 10's place, and 2 is at 100's place. Later on, we extended this idea to four-digit numbers. For example, the expansion of 5,278 is 5,278 is equal to 5,000 plus 200 plus 70 plus 8. That is equal to 5 into 1,000 plus 2 into 100 plus 7 into 10 plus 8 into 1. Here, 8 is at 1's place, 7 is at 10's place, 2 is at 100's place, and 5 is at 1,000's place. Similarly, we find expansion of five-digit numbers like 45,278. This is equal to 4 into 10,000 plus 5 into 1,000 plus 2 into 100 plus 7 into 10 plus 8 into 1. Here, 8 is at 1's place, 7 is at 10's place, 2 is at 100's place, 5 is at 1,000's place, and 4 is at 10,000's place. The number is read as 45,278. Example: read and expand the numbers. Solution: 1. The given number is read as 20,000 and expansion is 2 into 10,000. 2. The given number is read as 26,000 and expansion is 2 into 10,000 plus 6 into 1,000. 3. The given number is read as 38,400 and expansion is 3 into 10,000 plus 8 into 1,000 plus 4 into 100. 4. The given number is read as 65,740 and expansion is 6 into 10,000 plus 5 into 1,000 plus 7 into 100 plus 4 into 10. 5. The given number is read as 89,324 and expansion is 8 into 10,000 plus 9 into 1,000 plus 3 into 100 plus 2 into 10 plus 4 into 1. 6. The given number is read as 50,000 and expansion is 5 into 10,000. 7. The given number is read as 41,000 and expansion is 4 into 10,000 plus 1 into 1,000. 8. The given number is read as 47,300 and expansion is 4 into 10,000 plus 7 into 1,000 plus 3 into 100. 9. The given number is read as 57,630 and expansion is 5 into 10,000 plus 7 into 1,000 plus 6 into 100 plus 3 into 10. 10. The given number is read as 29,485 and expansion is 2 into 10,000 plus 9 into 1,000 plus 4 into 100 plus 8 into 10 plus 5 into 1. Introducing 1 lakh. The greatest 5-digit number is 99,999. Adding 1 to the greatest 5-digit number should give the smallest 6-digit number, that is, 99,999 plus 1 is equal to 1 lakh. This number is named 1 lakh. 1 lakh comes next to 99,999. 10 into 10,000 is equal to 1 lakh. We may now write 6-digit numbers in the expanded form as 2,46,853 is equal to 2 into 1 lakh plus 4 into 10,000 plus 6 into 1,000 plus 8 into 100 plus 5 into 10 plus 3 into 1. This number has 3 at 1's place, 5 is at 10's place, 8 is at 100's place, 6 is at 1,000's place, 4 is at 10,000's place, and 2 is at lakh place. Its number name is 2,46,853. 1. The given number is 4,57,199. 928. Number name is 4,57,928 and expansion is 4 into 1 lakh plus 5 into 10,000 plus 7 into 1,000 plus 9 into 100 plus 2 into 10 plus 8 into 1. 2. The given number is 4,07,928. Number name is 4,07,928 and expansion is 4 into 1 lakh plus 7 into 1,000 plus 9 into 100 plus 2 into 10 plus 8 into 1. 3. The given number is 3,53,500. Number name is 3,53,500 and expansion is 3 into 1 lakh plus 5 into 10,000 plus 3 into 1,000 plus 5 into 100. Larger numbers. If we add one more to the greatest 6-digit number, we get the smallest 7-digit number. It is called 10 lakh. If we add one more to the greatest 7-digit number, we get the smallest 8-digit number. It is called 1 crore. Complete the pattern. 9 plus 1 is equal to 10. 99 plus 1 is equal to 100. 999 plus 1 is equal to 1000. 9999 plus 1 is equal to 10,000. 99,999 plus 1 is equal to 1 lakh. 9,99,999 plus 1 is equal to 10 lakh. 99,99,999 plus 1 is equal to 1 crore. Remember, 100 is equal to 10 tens. 1000 is equal to 10 hundreds, which is equal to 100 tens. 1 lakh is equal to 100 thousands, which is equal to 1000 hundreds, and that is equal to 10,000 tens. 1 crore is equal to 100 lakhs. That is equal to 10,000 thousands, which is equal to 1 lakh hundreds, and that is equal to 10 lakh tens. We come across large numbers in many different situations. For example, while the number of children in your school or the number of people in the nearby town. An aid in reading and writing large numbers. Try reading the following numbers. A. 2,79,453. B. 50,35,472. C. 15 crore 27 lakh 375. D. 4 crore 3,50,894. Was it difficult? Sometimes the indicators are used to read and write large numbers, which help us to read and write large numbers easily. Indicators are also useful in writing the expansion of numbers. For example, writing the number under the tables O, T, and H, it is easy to read and write. For example, 1. 257. In 257, 7 is in units place, that is O. 5 is in tens place, that is T. And 2 is in hundreds place, that is H. An expansion is 2 into 100 plus 5 into 10 plus 7 into 1. 2. 2902. In 2902, 2 is under O, 0 is under T, 9 is under H, and 2 is under TH. An expansion is 2 into 1000 plus 9 into 100 plus 0 into 10 plus 2 into 1. One can extend this idea to numbers up to lakh as seen in the following table. For example, 1. In 7,34,543, 3 is in units place, 4 is in tens place, 5 is in hundreds place, 4 is in thousands place, 3 is in 10,000s place, and 7 is in lakhs place. Number name is 7,34,543. An expansion is 7 into 1 lakh plus 3 into 10,000 plus 4 into 1,000 plus 5 into 100 plus 4 into 10 plus 3 into 1. 2. In 32,75,829, 9 is in units place, 2 is in tens place, 8 is in hundreds place, 5 is in thousands place, 7 is in 10,000s place, 2 is in lakhs place, and 3 is in 10 lakhs place. Number name is 32,75,829. An expansion is 3 into 10 lakh plus 2 into 1 lakh plus 7 into 10,000 plus 5 into 1,000 plus 8 into 100 plus 2 into 10 plus 9 into 1. 3. In 2,57,34,543, 3 is in units place, 4 is in tens place, 5 is in hundreds place, 4 is in thousands place, 3 is in 10,000s place, 7 is in lakhs place, 5 is in 10 lakhs place, and 2 is in crores place. Number name is 2,57,34,543. and expansion is 2 into 1 crore plus 5 into 10 lakh plus 7 into 1 lakh plus 3 into 10,000 plus 4 into 1,000 plus 5 into 100 plus 4 into 10 plus 3 into 1. 4. In 65 crore 32 lakh 75,829. 9 is in units place. 2 is in tens place. 8 is in hundreds place. 5 is in thousands place. 7 is in 10,000s place. 2 is in lakhs place. 3 is in 10 lakhs place. 5 is in crores place. And 6 is in 10 crores place. Number name is 65 crore 32 lakh 75,829. An expansion is 6 into 10 crore plus 5 into 1 crore plus 3 into 10 lakh plus 2 into 1 lakh plus 7 into 10,000 plus 5 into 1,000 plus 8 into 100 plus 2 into 10 plus 9 into 1. Use of commas. You must have noticed that in writing large numbers in the sections above, we have often used commas. Commas help us in reading and writing large numbers. In our Indian system of numeration, we use ones, tens, hundreds, thousands, and then lakhs and crores. Indian system of numeration. The first comma comes after hundreds place, that is, 3 digits from the right, and marks thousands. The second comma comes 2 digits later, that is, 5 digits from the right. It comes after 10,000s place and marks lakh. The third comma comes after another 2 digits, that is, 7 digits from the right. It comes after 10 lakhs place and marks crore. For example, 1. 50 crore 80 lakh 10,592 in Indian system is given here. 2. 3 crore 32 lakh 40,781 in Indian system is given here. 3. 7 crore 27 lakh 5,062 in Indian system is given here. International system of numeration. In the international system of numeration, as it is being used, we have ones, tens, hundreds, thousands, and then millions. Commas are used to mark thousands and millions. It comes after every 3 digits from the right. We know that 1 million is equal to 10 lakh. Let's solve some examples. For example, number 5 crore 8 lakh 1,592. Insert commas in Indian and international system. This is as follows. In Indian system, this number is read as 5 crore 8 lakh 1,592. And in international system, it is read as 50,801,592. Example: insert commas suitably and write the names according to Indian and international system of numeration. A. 9 crore 99 lakh 46. B. 7 crore 89 lakh 21,092. C. 85 lakh 46,283. D. 4 crore 80 lakh 49,831. Solution: A. 9 crore 99 lakh 46. Insert commas in Indian and international system as follows. In Indian system, this number is read as 9 crore 99 lakh 46, and in international system it is read as 99,900,046. B. 7 crore 89 lakh 21,092. Insert commas in Indian and international system as follows. In Indian system, this number is read as 7 crore 89 lakh 21,092, and in international system it is read as 78,921,092. C. 85 lakh 46,283. Insert commas in Indian and international system as follows. In Indian system, this number is read as 85 lakh 46,283, and in international system it is read as 8,546,283. D. 4 crore 80 lakh 49,831. Insert commas in Indian and international system as follows. In Indian system, this number is read as 4 crore 80 lakh 49,831, and in international system it is read as 48,49,831. Large numbers in practice. Length. In earlier classes, we have learned that we use centimeter as a unit of length. For measuring the length of a pencil, the width of a book or a notebook, etc., we use centimeter. For measuring the thickness of a pencil, however, we find centimeter too big. We use millimeter to show the thickness of a pencil. A. 10 millimeters is equal to 1 centimeter. To measure the length of the classroom or the school building, We shall find centimeter too small. We use meter for the purpose. B. 1 meter is equal to 100 centimeters. So, 1 meter is equal to 100 into 10 millimeters, which is equal to 1000 millimeters. Even meter is too small when we have to state distances between cities, say Delhi and Mumbai or Chennai and Kolkata. For this, we need kilometers. C. 1 kilometer is equal to 1000 meters. Since 1 meter is equal to 1000 millimeter, therefore 1 kilometer is equal to 1000 meter, which is equal to 1000 into 1000 millimeter, and that is equal to 10 lakh millimeters. So, units of length are millimeter, centimeter, meter, and kilometer. Weight. We go to the market to buy rice or wheat. We buy it in kilograms. But items like ginger or chilies, which we do not need in large quantities, we buy in grams. We know 1 kilogram is equal to 1000 grams. Have you noticed the weight of the medicine tablets given to the sick? It is very small. It is in milligrams. 1 gram is equal to 1000 milligrams. So, units of weight are milligram, gram, and kilogram. Capacity. What is the capacity of a bucket for holding water? It is usually 20 liters. Capacity is given in liters, but sometimes we need a smaller unit, the milliliter. A bottle of hair oil or a soft drink have labels which give the quantity of liquid inside in milliliters. 1 liter is equal to 1000 milliliters. So, units of capacity are milliliters and liters. Remember, you should remember that among these, kilo is the greatest and milli is the smallest. Kilo shows 1000 times greater. Milli shows 1000 times smaller. That is, 1 kilogram is equal to 1000 grams. 1 gram is equal to 1000 milligrams. Similarly, centimeters shows 100 times smaller. That is, 1 meter is equal to 100 centimeters. Example. A bus started its journey and reached different places with a speed of 60 km per hour. The journey is shown here. A. Find the total distance covered by the bus from A to D. B. Find the total distance covered by the bus from D to G. C. Find the total distance covered by the bus if it starts from A and returns back to A. D. Can you find the difference of distances from C to D and D to E? E. Find out the time taken by the bus to reach 1. A to B, 2. C to D, 3. E to G, 4. Total journey. Solution. A. Total distance covered by the bus from A to D. Journey started with point A. So, initial or origin point is A. Total distance from A to D is equal to distance between A and B plus distance between B and C plus distance between C and D. That is equal to 4,170 plus 3,410 plus 2,160, which is equal to 9,740 kilometer. Thus, the total distance covered by the bus from A to D is 9,740 kilometer. B. Total distance from D to G is equal to distance between D and E plus distance between E and F plus distance between F and G. That is equal to 8,140 plus 4,830 plus 2,550, which is equal to 15,520 kilometer. Thus, the total distance covered by the bus from D to G is 15,520 kilometer. C. Total distance from A to A. This is equal to distance between A and B plus distance between B and C plus distance between C and D plus distance between D and E plus distance between E and F plus distance between F and G plus distance between G and A. So that is equal to 4,170 plus 3,410 plus 2,160 plus 8,140 plus 4,830 plus 2,550 plus 1,290, which is equal to 26,550 kilometer. Thus, the total distance covered by the bus from A to A is 26,550 kilometer. D. Distance covered by the bus from C to D is 2,160 kilometer. Distance covered by the bus from D to E is 8,140 kilometer. The straight method of subtraction is not possible because if 8,140 is subtracted from 2,160, the answer will be negative, but distance is never negative. So we subtract 2,160 from 8,140 and we get 5,980. Thus, the difference of distances from C to D and D to E is 5,980 kilometer. E. How to find time? Here we divide total distance by speed of the bus to get time. 1. Find out the time the bus takes to reach from point A to point B. For this, we divide the distance covered by the bus between A and B by the speed of the bus. That is, 4,170 divided by 60 km per hour. We get 69.5 hour. 69.5 hour is equal to 69 hour plus 0.5 hour, which is equal to 69 hour plus 0.5 into 60 minute. Here we convert hour into minute, and that is equal to 69 hour 30 minute. So, after 69 hours and 30 minutes, the bus reaches at point B starting from point A. 2. Find out the time the bus takes to reach from point C to point D. For this, we divide the distance covered by the bus between C and D by the speed of the bus, that is, 2160 divided by 60 km per hour. We get 36 hours. So, after 36 hours, the bus reaches at point D starting from point C. 3. First we find distance between E and G, then we find time. Total distance from E to G is equal to distance between E and F plus distance between F and G, that is equal to 4830 plus 2550, which is equal to 7380 km. Find out the time the bus takes to reach from point E to G. For this, we have to divide distance covered by the bus between E and G by the speed of the bus, that is, 7380 divided by 60 km per hour. We get 123 hours. So, after 123 hours, the bus reaches at point G starting from point E. 4. Find out the time the bus takes to reach from point A to A. We already have obtained the distance from point A to A, which is 26,550 km. So, if we divide 26,550 by 60 km per hour, we get 442.5 hours. 442.5 hours is equal to 442 hours plus 0.5 hour. That is equal to 442 hours plus 0.5 into 60 minutes. Here we convert hour into minute, and that is equal to 442 hours 30 minutes. So, after 442 hours and 30 minutes, the bus reaches at point A to A, that is, full round. Example. The population of Sundarnagar was 2,35,471 in the year 1991. In the year 2001, it was found to be increased by 72,958. What was the population of the city in 2001? Solution. The population of the city in 2001 is equal to population of the city in 1991 plus increase in population, that is equal to 2,35,471 plus 72,958, which is equal to 3,08,429. Answer. The population of the city in 2001 was 3,08,429. Example. In one state, the number of bicycles sold in the year 2002-2003 was 7,43,000. In the year 2003-2004, the number of bicycles sold was 8,100,000. In which year were more bicycles sold? And how many more? Solution. Clearly, 8,100,000 is more than 7,43,000. So, in that case, more bicycles were sold in the year 2003-2004 than in 2002-2003. Now, if we subtract 7,43,000 from 8,01,000, we get 57,100. Answer: 57,100 more bicycles were sold in the year 2003-2004. Example. The town newspaper is published every day. One copy has 12 pages. Every day, 11,980 copies are printed. How many total pages are printed every day? Solution. Each copy has 12 pages. Hence, 11,980 copies will have 12 into 11,980 pages. Now, if we multiply 12 by 11,980, we get 1,43,760 pages. Answer: every day, 1,43,760 pages are printed. Example. The number of sheets of paper available for making notebooks is 75,000. Each sheet makes 8 pages of a notebook. Each notebook contains 200 pages. How many notebooks can be made from the paper available? Solution. Each sheet makes 8 pages. Hence, 75,000 sheets will make 8 into 75,000 pages. Now, if we multiply 8 with 75,000, we get 6 lakh pages. Thus, 6 lakh pages are available for making notebooks. Now, 200 pages make one notebook. Hence, 6 lakh pages make 6 lakh divided by 200 notebooks. Therefore, 6 lakh is divided by 200 and we get 3,000. The answer is 3,000 notebooks. Example. Find the difference between the greatest and the least 5-digit number that can be written using the digits 6, 2, 7, 4, 3, each only once. Solution. Here the given digits are 6, 2, 7, 4, 3. To find the greatest number, we have to arrange the given digits in descending order. Descending order of the digits is 7, 6, 4, 3, 2. So the greatest number is 76,432. Similarly, for the smallest number, we have to arrange the given digits in ascending order. Ascending order of the digits is 2, 3, 4, 6, 7. So the smallest number is 23,467. Difference between the greatest number and the smallest number can be obtained by subtracting 23,467 from 76,432, and we get 52,965. Example: a student multiplied 7,236 by 65 instead of multiplying it by 56. By how much was his answer greater than the correct answer? Solution: to find the answer, first we have to multiply 7,236 by 56 and then multiply it by 65, and then we find the difference between the products we obtained. This method is so lengthy. In the second method, first we find the difference between the numbers 65 and 56, which is 9. Then we multiply 9 by 7,236 and get 65,124. That is the required answer. Therefore, his answer was greater than the correct answer by 65,124. Example: a vessel has 4 liter and 500 milliliter of curd. In how many glasses, each of 25 ml capacity, can it be filled? Solution: first, we convert liter into milliliter. 1 liter is equal to 1000 milliliter. Therefore, 4 liter is equal to 4000 milliliter. 4 liter and 500 milliliter is equal to 4500 milliliter. Now, number of glasses that can be filled is equal to 4500 divided by 25. So, we divide 4500 by 25 and we get 180. Therefore, 180 glasses can be filled. Estimation. News. 1. India drew with Pakistan in a hockey match watched by approximately 51,000 spectators in the stadium and 40 million television viewers worldwide. 2. Approximately 2,000 people were killed and more than 50,000 injured in a cyclonic storm in coastal areas of India and Bangladesh. 3. Over 13 million passengers are carried over 63,000 kilometer route of railway track every day. Can we say that there were exactly as many people as the numbers quoted in these news items? For example, in news item 1, were there exactly 51,000 spectators in the stadium? Or did exactly 40 million viewers watch the match on television? Obviously not. The word approximately itself shows that the number of people were near about these numbers. Clearly, 51,000 could be 50,800 or 51,300 but not 70,000. Similarly, 40 million implies much more than 39 million but quite less than 41 million, but certainly not 50 million. The quantities given in the examples above are not exact counts but are estimates to give an idea of the quantity. Where do we approximate? Imagine a big celebration at your home. The first thing you do is to find out roughly how many guests may visit you. Can you get an idea of the exact number of visitors? It is practically impossible. The finance minister of the country presents a budget annually. The minister provides for certain amount under the head Education. Can the amount be absolutely accurate? It can only be a reasonably good estimate of the expenditure the country needs for education during the year. Estimating to the nearest tens by rounding off. Look at the figure and answer the following questions. A. Find which flags are closer to 260. Answer. Flag post on 261 and 263 are closer to 260. B. Find the flags which are closer to 270. Answer. Flag post on 267 and 269 are closer to 270. Locate the number 10, 17 and 20 on your ruler. Is 17 nearer to 10 or 20? 17 is nearer to 20 because the gap between 17 and 10 is 7 and the gap between 17 and 20 is 3. So 17 is nearer to 20. So we round off 17 as 20, correct to the nearest tens. Now consider 12, which also lies between 10 and 20. However, 12 is closer to 10 than to 20. So we round off 12 to 10, correct to the nearest tens. We see that the numbers 1, 2, 3 and 4 are nearer to 0 than to 10. So we round off 1, 2, 3 and 4 as 0. Numbers 6, 7, 8, 9 are nearer to 10. So we round them off as 10. Number 5 is equidistant from both 0 and 10. It is a common practice to round it off as 10. Example. Round these numbers to the nearest tens. 28, 32, 52, 41, 39, 48, 64, 59, 99, 216, 1453, 2936. Solution. 28 rounds off to 30. 32 rounds off to 30. 52 rounds off to 50. 41 rounds off to 40. 39 rounds off to 40. 48 rounds off to 50. 64 rounds off to 60. 59 rounds off to 60. 99 rounds off to 100. 216 rounds off to 220. 1453 rounds off to 1450. 2936 rounds off to 2940. Estimating to the nearest hundreds by rounding off. Is 410 nearer to 400 or to 500? 410 is closer to 400, so it is rounded off to 400, correct to the nearest hundred. 889 lies between 800 and 900. It is nearer to 900, so it is rounded off to 900, correct to nearest hundred. Numbers 1 to 49 are closer to 0 than to 100, and so are rounded off to 0. Numbers 51 to 99 are closer to 100 than to 0, and so are rounded off to 100. Number 50 is equidistant from both 0 and 100. It is a common practice to round it off as 100. Example: round these numbers to the nearest hundreds. 841, 2546, 168, 9537, 286, 149, 49,730, 5,750, 9,870. Solution: 841 rounds off to 800. 2,546 rounds off to 2,500. 168 rounds off to 200. 9,537 rounds off to 9,500. 286 rounds off to 300. 149 rounds off to 100. 49,730 rounds off to 49,700. 5,750 rounds off to 5,800. 9,870 rounds off to 9,900. Estimating to the nearest thousands by rounding off. We know that numbers 1 to 499 are nearer to 0 than to 1000. So, these numbers are rounded off as 0. The numbers 501 to 999 are nearer to 1000 than to 0, so they are rounded off as 1000. Number 500 is also rounded off as 1000. Example: round these numbers to the nearest thousands. 2,573, 6,404, 7,805, 53,552, 65,437, 3,499. Solution: 2,573 rounds off to 3,000. 6,404 rounds off to 6,000. 7,805 rounds off to 8,000. 53,552 rounds off to 54,000. 65,437 rounds off to 65,000. 3,499 rounds off to 3,000. Estimating outcomes of number situations. We add numbers by following the algorithm, that is, the given method, systematically. We write the numbers taking care that the digits in the same place, ones, tens, hundreds, etc., are in the same column. For example, 3,946 plus 6,579 plus 2,050 is written as. We add the column of ones and, if necessary, carry forward the appropriate number to the tens place, as would be in this case. We then add the tens column, and this goes on. Complete the rest of the sum yourself. This procedure takes time. There are many situations where we need to find answers more quickly. For example, when you go to a fair or the market, you find a variety of attractive things which you want to buy. You need to quickly decide what you can buy. So you need to estimate the amount you need. It is the sum of the prices of things you want to buy. A trader is to receive money from two sources. The money he is to receive is rupees 13,569 from one source and rupees 26,785 from another. He has to pay rupees 37,000 to someone else by the evening. He rounds off the numbers to their nearest thousands and quickly works out the rough answer. He is happy that he has enough money. There are no rigid rules when you want to estimate the outcomes of numbers. The procedure depends on the degree of accuracy required and how quickly the estimate is needed. The most important thing is how sensible the guessed answer would be. To estimate sum or difference. As we have seen, we can round off a number to any place. So, when you estimate any sum or difference, you should have an idea of why you need to round off and therefore the place to which you would round off. Look at the following examples. Example: estimate 5,290 plus 17,986. Solution: you find 17,986 greater than 5,290. Round off to thousands. 17,986 rounds off to 18,000 and 5,290 rounds off to 5,000. Estimated sum of 18,000 and 5,000 is 23,000. You may attempt to find the actual answer and verify if the estimate is reasonable. Example: estimate 5,673 minus 436. Solution: to begin with, we round off to thousands. 5,673 rounds off to 6,000 and 436 rounds off to 0. Estimated difference of 6,000 and 0 is 6,000 and the actual answer is 5,237, which is smaller than 6,000. So our estimate is wrong. This is not a reasonable estimate. To get a closer estimate, let us try rounding each number to hundreds. 5,673 rounds off to 5,700 and 436 rounds off to 400. Estimated difference of 5,700 and 400 is 5,300, which is nearer to the actual answer 5,237. So then our estimate is right. Example. Estimate 439 plus 334 plus 4,317. Solution. Here we round off to hundreds. 439 rounds off to 400. 334 rounds off to 300. And 4,317 rounds off to 4,300. Estimated sum of 400, 300 and 4,300 is 5,000, which is nearer to the actual answer 5,090. So our estimate is right. Example. Estimate 1,08,734 minus 47,599. Here's the solution. Here we round off to 10,000s. We have learnt the rounded form of number nearest to 10, 100 and 1,000. In the same way, we can round off the numbers nearest to 10,000. The numbers 0 to 4,999 are rounded off to 0 because all these numbers are closer to 0 than to 10,000. Similarly, the numbers 5,000 to 9,999 are rounded off to 10,000 because all these numbers are closer to 10,000 than they are to 0. 1,08,734 rounds off to 1,10,000, correct to nearest 10,000. 47,599 rounds off to 50,000, correct to nearest 10,000. Estimated difference of 1,10,000 and 50,000 is 60,000, which is nearer to actual answer 61,135. So, our estimate is right. To estimate products. We get estimate answer for addition and subtraction for the earlier examples. Similarly, we get estimate answer for multiplication. Example, what is the estimate for 19 into 78? Solution, here we round off to tens. If we approximate 19 to the nearest tens, we get 20, and then approximate 78 to the nearest tens, we get 80. An estimated multiplication of 20 and 80 is 1600. Example: estimate 63 into 182. Solution: if we approximate both to the nearest hundreds, we get 100 into 200, that is equal to 20,000. This is much larger than the actual product. So what do we do? To get a more reasonable estimate, we try rounding off 63 to the nearest 10, that is 60, and also 182 to the nearest 10, that is 180. Now we get 60 into 180, that is 10,800. This is a good estimate, but it is not quick enough. If we now try approximating 63 to 60 and 182 to the nearest 100, that is 200, we get 60 into 200, and this number 12,000 is a quick as well as a good estimate of the product. The general rule that we can make is, therefore, round off each factor to its greatest place, then multiply the rounded off factors. Example: estimate the following products using general rule. A. 479 into 81. B. 1291 into 592. C. 37 into 1889. Solution: A. 479 into 81. 479 is rounded off to 500, that is by rounding off to hundreds, and 81 is rounded off to 80, that is by rounding off to tens. The estimated product of 580 is 40,000. B. 1291 into 592. 1291 is rounded off to 1300, that is rounding off to hundreds, and 592 is rounded off to 600, that is rounding off to hundreds. The estimated product of 1300 and 600 is 7,80,000. C. 37 into 1889. 37 is rounded off to 40, that is rounding off to tens, and 1889 is rounded off to 2000, that is rounding off to thousands. The estimated product of 2040 is 80,000. Using brackets. Seema bought 6 notebooks from the market and the cost was Rs 10 per notebook. Her sister Meera also bought 7 notebooks of the same type. Find the total money they paid. Seema calculated the amount like this: 6 into 10 plus 7 into 10, which is equal to 60 plus 70, and that is equal to 130. Answer: Rs 130. And Meera calculated the amount like this. 6 plus 7 is equal to 13. 13 into 10 is equal to 130. Answer: Rupees 130. You can see that Seema's and Meera's ways to get the answer are a bit different, but both give the correct result. Seema says what Meera has done is 7 plus 6 into 10. Appu points out that 7 plus 6 into 10 is equal to 7 plus 60, which is equal to 67. Thus, this is not what Meera had done. All the three students are confused. To avoid confusion in such cases, we may use brackets. We can pack the numbers 6 and 7 together using a bracket, indicating that the pack is to be treated as a single number. Thus, the answer is found by 6 plus 7 into 10, which is equal to 13 into 10, and that is equal to 130. Expanding brackets. Now observe how the use of brackets allows us to follow our procedure systematically. We solve examples easily with the use of brackets. Let us solve some examples. Example: expansion of 7 into 109. Solution: 7 into 109 is equal to 7 into 100 plus 9. That is equal to 7 into 100 plus 7 into 9, which is equal to 700 plus 63, and that is equal to 763. Example: expansion of 17 into 109. Here's the solution. 17 into 109 is equal to 10 plus 7 into 109. So that is equal to 10 into 109 plus 7 into 109, which is equal to 10 into 100 plus 9 plus 7 into 100 plus 9. That is equal to 10 into 100 plus 10 into 9 plus 7 into 100 plus 7 into 9, which is equal to 1000 plus 90 plus 700 plus 63, that is 1790 plus 63, which is equal to 1853. Example: expansion of 102 into 103. Solution: 102 into 103 is equal to 100 plus 2 into 100 plus 3, that is equal to 100 plus 2 into 100 plus 100 plus 2 into 3. That is equal to 100 into 100 plus 2 into 100 plus 100 into 3 plus 2 into 3. That is equal to 10,000 plus 200 plus 300 plus 6, which is equal to 10,000 plus 500 plus 6, and that is equal to 10,506. Roman numerals. We have been using the Hindu-Arabic numeral system so far. This is not the only system available. One of the early systems of writing numerals is the system of Roman numerals. This system is still used in many places. For example, we can see the use of Roman numerals in clocks. It is also used in the classes in the school timetable, etc. The Roman numerals shown here denote 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 respectively. This is followed by 11, 12 till 20. Some more numerals are denoted in Roman numerals as shown here. 1, 5, 10, 50, 100, 500 and 1000. The rules for the system are: A. If a symbol is repeated, its value is added as many times as it occurs. That is, II is equal to 2, XX is equal to 20, and XXX is 30. B. A symbol is not repeated more than 3 times, but the symbol V, L and D are never repeated. C. If a symbol of smaller value is written to the right of a symbol of greater value, its value gets added to the value of the greater symbol. VI is equal to 5 plus 1, that is equal to 6. XII is equal to 10 plus 2, that is equal to 12. LXV is equal to 50 plus 10 plus 5, that is equal to 65. D. If a symbol of a smaller value is written to the left of a symbol of greater value, its value is subtracted from the value of the greater symbol. IV is equal to 5 minus 1, that is equal to 4. IX is equal to 10 minus 1, that is equal to 9. XL is equal to 50 minus 10, that is equal to 40. XC is equal to 100 minus C, that is equal to 90. E. The symbols V, L and D are never written to the left of a symbol of greater value. That is, V, L and D are never subtracted. The symbol I can be subtracted from V and X only. The symbol X can be subtracted from L, M and C only. Example. Write in Roman numerals A. 69, B. 98. Solution. A. 69 is equal to 60 plus 9. So that is equal to 50 plus 10 plus 9, which is equal to LX plus IX, and that is equal to LXIX. B. 98 is equal to 90 plus 8, which is equal to 100 minus 10 plus 8. That is equal to XC plus VIII, which is equal to XCVIII. Example: write in Roman numerals A 154, B 1492, C 3495. Solution: A 154. 154 is equal to 100 plus 50 plus 4, which is equal to C plus L plus IV, which is equal to CLIV. B 1492 is equal to 1000 plus 400 plus 92, which is equal to 1000 plus 500 minus 100 plus 100 minus 10 plus 2. That is equal to M plus CD plus XCII, which is equal to MCDXCII. C 3495 is equal to 3000 plus 495, which is equal to 3000 plus 500 minus 100 plus 100 minus 10 plus 5. That is equal to MMM plus CD plus XCV, which is equal to MMM CD XCV. Example: write in numerals A LXX, B MMLDXC, C MDXCV. Solution: A LXX is equal to L plus XX, which is equal to 50 plus 20, which is equal to 70. B MMLDXC is equal to MM plus LD plus XC, which is equal to 2000 plus 450 plus 90, that is equal to 2450 plus 90, which is equal to 2540. C MDXCV is equal to M plus D plus XCV. That is equal to 1000 plus 500 plus 95, which is equal to 1595. What have we discussed? 1. Given two numbers, one with more digits is the greater number. If the number of digits in two given numbers is the same, that number is larger which has a greater leftmost digit. If this digit also happens to be the same, we look at the next digit and so on. 2. In forming numbers from the given digits, we should be careful to see if the conditions under which the numbers are to be formed are satisfied. Thus, To form the greater 4-digit number from 7, 8, 3, 5 without repeating a single digit, we need to use all 4 digits. The greatest number can have only 8 as the leftmost digit. 3. The smallest 4-digit number is 1000. It follows the largest 3-digit number, 999. Similarly, the smallest 5-digit number is 10,000. It is 10,000 and follows the largest 4-digit number, 9,999. 4. Use of commas helps in reading and writing large numbers. In the Indian system of numeration, we have commas after 3 digits starting from the right and thereafter every 2 digits. The commas after 3, 5 and 7 digits separate thousand, lakh and crore respectively. In the international system of numeration, commas are placed after every 3 digits starting from the right. The commas after 3 and 6 digits separate thousand and million respectively. 5. Large numbers are needed in many places in daily life. For example, for giving number of students in a school, number of people in a village or town, money paid or received in large transactions, that is, buying and selling, in measuring large distances, say between various cities in a country or in the world, and so on. 6. Remember, kilo shows 1000 times larger, centi shows 100 times smaller, and milli shows 1000 times smaller. Thus, 1 kilometer is equal to 1000 meters. 1 meter is equal to 100 centimeters or 1000 millimeters, etc. 7. There are a number of situations in which we do not need the exact quantity but need only a reasonable guess or an estimate. For example, while stating how many spectators watched a particular international hockey match, we state the approximate number, say 51,000. We do not need to state the exact number. 8. Estimation involves approximating a quantity to an accuracy required. Thus, 4,117 may be approximated to 4,100 or to 4,000, that is, to the nearest 100 or to the nearest 1,000, depending on our need. 9. In number of situations, we have to estimate the outcome of number operations. This is done by rounding off the numbers involved and getting a quick, rough answer. 10. Estimating the outcome of number operations is useful in checking answers. 11. Use of brackets allows us to avoid confusion in the problems where we need to carry out more than one number operation. 12. We use the Hindu-Arabic system of numerals. Another system of writing numerals is Roman system.